Hello guys, today I'm going to explain you how can we solve this problem called counting bits. This problem from Leetcode's May challenge, and the problem statement says given a non-negative integer number num for every number between 0 to this num including 0 and num as well, calculate the number of ones in their binary representation and return them as an array. So for example, let's take this one. So what we need to do is we need to calculate number of ones in their binary representation for 0, 1 and 2, and then return them as an array. Like for 0 the number of ones are 0, in case of 1 the number of 1 will be 1, and in case of 2 the number of ones are 1 as well. Similarly, if you can see till 2 we have seen for 3, 4 and 5. For 3 the representation is 1 1, so number of ones are 2. For 4 the representation is 1 0 0, so the number of ones are 1. And then we have 5, which is 1 0 1, and here as you can see the number of ones are 2. Alright guys, so now the simplest approach is that we can take one number at a time and we are trying to find the number of ones in it. So it's similar to finding the binary representation of a number, where we will keep on checking whether this current number is an odd number or not. If the current number is odd, that means the current rightmost bit would be 1, and if it is even, the rightmost bit would be 0. So get the third bit, the rightmost bit currently. What we are going to do is we'll check whether this particular number is odd or even. So if this is odd, as you can see this is odd, so we will increase our counter and we'll try to get the next bit. To get the next bit we have to divide it by 2. Now we have divided and this becomes 1 0. So to get the current bit, again we'll check whether this is odd or even. This is even, so we'll not increase our counter because this is 0, and then we'll try to find the next bit's information. So we'll divide by 2 again, and this gives us 1. So now 1 is an odd number, so we will increase this to 2, and we will change this to 0 1. Then the next number is 0. So 0, after 0 we should not continue, because dividing 0 by 2 would always give us 0. So we can end this here, and 0 is obviously an even number, so we cannot increase our counter anymore. So it gives us that as you can see we have reached the end, and we can see that the number of ones are 2. Simply we can take any other example and we can check this method works well. But as given in the problem statement, that as you can see, computing the number of ones in this manner would take the amount of the time which would be equal to the amount of digits in a particular number. So because we can see we did this for 3 times, if this number was let's say if this number was a bit long, we would have to do for each number, and then we'll try to find out what's the current what will be the total number of ones. So as also given in the example, given in the question, that we should not take more than O of n time, like we should do it in a linear time. How can we do this? Let's try to see. Before moving ahead, let's try to code this one and see if we can pass this test case. And so what I said is we are going to calculate the number of ones in each number one by one. So let's call this number x currently, which would be I, and then while x is not equals to 0, in fact we need to start from 0 here. While x is not equals to 0, also we would need a vector of answer. So let's declare them, and we are going to maintain a count of number of ones in this particular number. So we will check if x is an odd number, that means x percent 1 should be x and 1 should give us 1, and if it is, then we'll increase the counter by 1. And what are we going to do in other cases is divide x by 2 to get the information from the next bit. And what are we going to do after we have done this is we'll push this counter into the array, and once we have done this for all of them, we'll return it. Let's see if it works. answer dot push back. Right, it works. So I should have tried with 5 earlier so that we could have seen. Okay, it seems to be working, but let's see if it gets accepted as well. So it's accepted. However, it is written that we should try to aim for the more optimized version. Let me try to explain how we can do this. There is also a small disclaimer given that we should not use any inbuilt function. Like there is one inbuilt function in C++ which gives you the number of ones in one particular number. So we should not use any such inbuilt function. We should try to build some our own algorithm. And also there is a note given that we can have at max O of n space complexity as well. So let's talk about the optimized approach. As we saw, like to get number of ones in a particular number, we need to traverse back. We need to traverse the whole digit for this given number to know how many ones are contained there. So what we were doing is basically checking how this number was formed. If there is a better way to do this, we can, if we can check without traversing all the digits, if there is a better way to check how many numbers this how many ones this number contained while being constructed, that would help us. So let's see how a particular number is constructed from one of the previous numbers. So basically, if you look closely, all the numbers here, let me just speak. Look closely, all the numbers which has let's say for example 2 digits in its binary representation are actually can be found by adding 1 to the binary to all the numbers who has only 1 digits in its binary representation. For example, 2 and 3 can be found by appending 1 to the left of the leftmost bit in 0 and to the left of the leftmost bit in 1, so we can find 2 and 3. Similarly, if we talk about 4, what we can do is we can try to append the leftmost bit 1 to the leftmost bit of 1 for 0, so this can also be written as 0 0, so this would become 1 0 0. And then to get 5, we can just append 1 0, like this could also be written as 0 1, so this can be changed to 1 0 1, which is this one. And similarly for the other 2 digit which are here, so we could simply borrow and append 1 in front of them to get the 3 digits numbers. And once we can continue and check for the similarly for the 4 digits that we need to, for the 4 digits what we need to do, we need to find all the digits from 0 from all the 1 digits till all the 2 digits, all the 3 digits, and just append 1 in front of them, 1 to the leftmost bit of their binary representation. Now let's consider why do we append 1. And we do that because we have seen that we calculated all the possible numbers that we can create with using 3 bits only. So we should start building all the numbers that we can build using 4 digits, and we can start using we can start from first. So the first number that can be created using 4 digits should have 1 in its leftmost bit, and then we can try to create all the digits by changing the numbers here, like all the possible numbers that we can create using 3 digits. Alright guys, so now that we have seen that we can find the number of ones in a particular number without having to traverse through all the digits of that particular number, what we can do here is we can just try to see when this particular length is going to change from 2 to 3 and 3 to 4 and so on. So now let's see, once we reach a particular number, let's say for example 4, this number should have changed the length, and then we should start adding 1 from the beginning. What I mean is, let's say till here the length was 2. Now once we reach 4, we know that the length is going to change, and then we should start building the next numbers, like for 4 5 6 7 we should start adding ones to these number. And then again, once we reach till here, let's say till 7, and then starting when we'll reach 8, we need to change our iterator to 0, and then again we need to add the 1 to the existing value of this one. Like for 0 it was 0, so we'll add 1 for 8, we will add 2 for 9, we will add 3, we will add not sorry we will add 1 to 1 for 9, and we'll add 1 to 2 for 10, and so on. So the only thing that we want to discuss is how are we going to know whether this particular length is going to change. If we look closely, we can understand that this transitioning from length current length to next length, like length plus 1 in the binary representation, is happening at the digits which are power of 2. So for example, from 0 from 1 to 2, from length transition of 1 to to the length 2, this happens at 2, and then for 2 to 3 this happens at 4, and then from 3 to 4 length this is happening at 8. So if we could check that the current number is a square of a power of 2, we could simply start our iterator from 0 and just keep on adding 1 to the next numbers, the value of the next numbers. So for example, for 8 also we could know that this is a power of 2, so we can start building the numbers from 8 onwards by just appending the answer for 0, answer for 1, by adding 1 to the answer of 0, to the answer of 1, and answer of 2, and so on till 7. So to check whether a number is a power of 2, what we can do is simply try to do AND operation with the current number and the number minus 1, and check if this number is equals to 0 or not. So let's take an example. Let's say, for example, in case of 4, as we know, all the digits, all the digits within the binary representation of 4 are 0 except the last one, and the number just behind this one, that is 3, would have all the digits as 1. So if we take AND operation with these two, it would always result in 0. So if we could consider 8 as well, let's see what happens, because 8 has 1 in the leftmost bit and 7 has all the bits set, so they both also would result in 0 if we take AND operation between both of these. So I guess that's enough for the explanation. Let's see how we can code this. So as we said, we need a answer array, and we are going to push back 0 into answer because there is no number behind 0, so we can simply push it and check if num was 0, then we could simply return answer. And then we are going to start from 1 till we reach this number, and we are going to push back this number plus 1. What are we supposed to do here is we should check if this current number is the perfect if it is a power of 2, that means if I and I minus 1 is going to give us 0, then what are we going to do? We need also, as I said, that we needed an iterator. Let's keep this iterator as idx, then we are just going to set this back to 0. Otherwise we need to push back the answer for this particular number would be 1 plus the number the answer for idx, and we just increase this counter as well. So let's return answer. So let's submit and check if it works. Alright, so yeah, it worked. So I hope I was able to explain it to you guys. Thanks for watching this video. Please like and hit subscribe button.